So question 94 today in class followed a progression of equations, of problems rather, where we saw that we can basically write a system of equations in order to figure out what the parameters are for either a line or, in this case, for an exponential curve. So, for example, it says write the general form of an exponential function that has an asymptote at y equals 0. So that looks like this, right? It's y equals a times b raised to the x power. So as long as our asymptote's at 0, the two parameters that we have for an exponential curve are what's our starting value, right? What's our zeroth term, if you will, and what's our multiplier? What's the ratio between successive terms? And that's b. And you can see b to the x power. So if I look at this, I have two xy values. And my strategy here is I'm going to use both of them. I'm going to use this xy pair and I'm going to use this xy pair in order to write two different equations, and I'm going to solve them like a system of equations. So I could write down, for example, that not y, I'm going to use this first point, so it's 144. I can write 144 equals a times b raised to the second power. That's 1, and it comes from this first point, right? And you can see I used the y and the x value. X was 2, so that's up in my exponent, and y was 144. The other equation I can write is 729 equals a times b to the sixth power. So this is coming from my second point. So with these 2 points now, right, and these two equations, I basically set out to solve what a and b are. And if I know a and b, I would know the two parameters that describe this exponential curve completely. And a couple different strategies, and we looked at both in class. And one of these is quite similar to a homework problem from, I believe, last night. But I think what I'm going to do is I'm going to solve this first equation for a. I'm going to isolate a. So I'm going to do that by dividing both sides by b squared. So I get 144 divided by b to the second power equals a. And what I'm going to do now is using that value of a. In other words, this is a, right? I'm going to place that into this second equation. I'm going to do substitution. So I got a alone, and now I'm going to do substitution. Um, so the substitution looks like this. Oops. I'm going to write down, let me get this over a little bit more. I'm going to write down 729 equals 144 divided by b to the second power times b to the sixth power. So for convenience here, I'm going to write, and for clarity, I'm going to write b to the sixth power over 1, so I can see it as a fraction times a fraction. And when I do that, I see, oh, there's clearly a giant 1 here, right? Both the numerator and denominator have two factors of b that I can pair up and eliminate. In fact, if I do that, this would become 729 equals 144 times b to the fourth power. So if you'd like to see that in slow motion, I'm just looking at this b to the sixth over b to the second power. I can rewrite b to the sixth as b squared times b to the fourth over b to the second power. So you can see there's this value of 1, right? B squared over b squared, and I'm left with b to the fourth. To solve this, then I'm going to divide both sides by 144. So I have 729 divided by 144 is b to the fourth power. And the tool that we've been using to deal with this is, in order to make this just a b on this side, I've been raising both sides to the 1/4 power. And I'm not even simplifying the 729 over 144. I'm just leaving it there. When I do that, on the right hand side, I'm going to be left with b, right? B to the fourth power, or b to the fourth raised to the 1/4 is b to the first power. And over on the other side, let me grab my calculator. Oops, there it is. Let's go ahead and put this in here. This should become, I think I'll do this in one step. So I'm going to go open parentheses. Actually, I'll make it look pretty. So I'm going to grab the fraction template. And in the numerator, I'm going to enter 729. Oops, 729. I didn't even hit 7. 729. And my denominator, I'm going to enter the 144. And I'm going to leave this and raise that entire fraction. Ooh, this is a little confusing. I know that I am raising this fraction to this power, but perhaps you may see this as me only raising the numerator to the power, and I don't like that ambiguity. That makes me uncomfortable. So I'm going to go ahead and, what is 729 divided by 144? Okay, it's 5.0625. I'll just take that and I'll raise that to the 1/4 power. Oh, well, that's pleasant. That's contrived. That's nice. So I get that's 3/2. I get b is 3/2 or 1.5. Well, that's fabulous because now that I know the value of b, um, I can use that to figure out what a is. And once I know a, I would know both parameters for this. So this is definitely part of my solution. The other part is I need to figure out what a is. And if you look right here, a is 144 divided by b squared. So I think I could do that. I'll just take 144 and divide that by, let me just put 1.4 or 1.5, and I'll square that denominator. 64. Okay, so I believe that a is 64. So I'm a little unsure of how my calculator behaved with some of those expressions. So I want to definitely check this answer, but I think it's y equals a 64 times b 3/2 raised to the x power. So let's plug in 2 and see if we really do get 144. So I'm going to check this answer by just plugging in the original point. So when I put in 2, it should give me 144. So I go 64 times open parentheses 3 divided by 2. I'll close the parentheses and raise that to the second power. This should say 144, and it does. I'll just go up and grab this expression again, but this time I'll modify the 2 and make it a 6, and this should give me a value of 729. And it does, yeah. So definitely this is the equation of the exponential curve that has an asymptote of 0 and goes through the 2 points, 2, 144, and 6, 729. So this is the technique, and it's based on solving a system of equations. One of the things that came up in class was someone said, well, why can't I just use the elimination method? And I really encourage you to think about this deeply and maybe look at some numerical examples to answer that question. But this is multiplication, right? It's not mx plus b like it was for the linear case. This is a times b squared. So if I subtract or if I intend to subtract a or add an a and a negative a from both sides, because it's locked up with this b squared and the b to the sixth, it's not exactly what you think it is. So think about that a little bit more deeply and decide for yourself whether or not you want to use the elimination method here or not. But I claim substitution works quite nicely. And honestly, I could get a alone in both equations and then use the equal values method as well. But this was doing it using, I isolated a in the first equation and then substituted into the second.